So we'll be discussing a topic that is LSTM, that is long short-term memory. Now there is a problem with RNN, and the problem is that it remembers only short-term dependencies to some extent. Short-term dependencies here means that the sequence is short, the sequence of words is short. There is a small sentence. And when there are long-term dependencies, this RNN struggles a lot with this. So this is the problem. And in RNN, there is a problem of vanishing gradients. The gradients tends to become smaller. The gradients become near to zero. And when gradients become near to zero, accuracy is not getting enhanced. So because of this problem, LSTM came. Now LSTM addresses this problem of long-term and short-term dependencies. How come the problem is addressed? Because it captures both short-term as well as long-term dependencies. Now short-term dependency here does not mean just the previous step. It means a few previous steps. Similarly, long-term dependencies means more number of previous steps. So it addresses both short-term and long-term dependencies. So from here we could derive the definition that LSTM, it is a type of recurrent neural network that learns both short-term and long-term dependencies in sequential data or in time series data. So this is the definition. Then is the key features that are part of LSTM is the memory cell that stores the past information. And there are three gates in this memory cell: input gate, forget gate, and output gate. Input gate tells us what information is to be stored in the memory. Forget gate tells what information is to be discarded, and output gate tells which information from the current state should be used as the output. So these are the three gates. Diagrammatically we can see here xt is the input that we are giving to this memory cell. ht minus 1 is the hidden state from the previous time step. Then there are three gates: ft, it, and ct and ot. ft is the forget gate, what information is to be discarded. it, what information is to be retained. ot, what information is to be outputted. Then there is this long term sequence ct minus 1 and ct. This long term sequence is what is the backbone of this entire network that remembers the long term sequences. Now let us take this example where the sentence is I want to go to the dash. We have to predict the next word in the sequence. Now for this, first of all, we need to give training to LSTM, and after we give training to LSTM, the probability distribution can be generated for different words, where we can have words like store, park, beach, library, or mall. So the output could be I want to go to park, I want to go to beach, I want to go to library, I want to go to mall. So such kind of words can be there, and the highest probability, let's say, comes out to be of park. So the next prediction could be I want to go to the park. This is how LSTM predicts a given word in the sequence. Now the application areas remain the same as that of an RNN. That is, it can be used for sentiment analysis, it can be used for speech processing, where we have speech synthesis, that is text to speech conversion, for audio processing, that is automatic music generation, for time series analysis, stock price prediction. So these are a few application areas. The only difference that lies with the RNN is that all these applications can be used both for short-term sequences as well as for long-term sequences. Whereas in RNN, it is just used for short-term sequences only. So this was the content about this lecture, and if you got some knowledge out of it, then do like, comment, share, and subscribe. And thanks for watching.